Okay, so with this session, we'll be doing some questions using the index laws that are a bit more challenging, um, and they're from a worksheet you may have received. So I'm just picking some random ones just to cover some of our basic skills. And some of these are just more challenging because they involve fractions. And there is an index law we haven't covered, the last index law, that involves numbers to the power of fractions. So for example, you might come across a question like this for end up with something like 4 to the power of a half. Now, if you haven't learned that last index law, then don't worry about it. You can leave your numbers like this, but this actually is saying the square root of 4. And that is an index law we haven't covered, like I said, and we won't be covering it. So it's okay if your numbers don't look the same as the one on your worksheet, if you're doing the worksheet. Now, the reason why they equal each other is because remember there's an invisible 2 out here and an invisible 1 in front of the 4. Whenever you have a fraction as a power and a number, all you're going to do is the number on the bottom goes on the outside. In this case, it's invisible because the square root is invisible. That 2 is invisible. And the number on top just goes down on the bottom. And that's it. And the square root of 4, so 4 to the power of a half, if you put it on your calculator, it will give you 2 because they are both the same, saying the same thing. And like I said, it's the last index law, which we haven't covered yet, and we won't be. You do that later on. So if your numbers are coming up like this, and it's different to what you have on your worksheet, that's fine. So our first question, you notice it involves negative powers. And our first step will be to get rid of our brackets, just like if we had BODMAS, brackets are first. And we've got a negative 6 out here, and we multiply it with every other power inside the bracket. If you want to do arrows to remind you, in little times to remind you, you are multiplying those powers, not adding them. So this will stay the same for now. We have 2 m to the power of 3, n to the power of negative 5, times, I now have m to the power of 2 times negative 6 is negative 12, and negative 3 times negative 6 will give me a positive 18. And just double check your powers to make sure you haven't made a mistake. And now we know that when we multiply variables or the same base, we can add their powers. And at this stage, there are 2 things you can do. You can just go ahead and add the powers, or if you wanted to make the powers positive first, by using that negative index law, how we make powers positive, you can. For this example, I will be leaving them in this way and just adding the powers. So I'll put a plus there to remind me that I am now adding the powers, because we know when we multiply, that first index law we learned, we add the powers. Now 2 times a 1, the positive 1 is just 2, so 2 will stay the same. I've got my bases are m and the other one is n. So that will be my final answer, but of course, sorry, not my final answer, but my next step. But of course, we have to add the powers. So 3 plus a negative 12. So use your calculator to help you if you get stuck with negatives. So 3 plus a negative 12 is 9. Oh, sorry. No, is negative 9. Yep. 3, so 3 plus a negative 12, yeah, negative 9. And negative 5 plus 18, that will leave us with positive 13, because we're going in the positive end. Okay, and now we know that we don't stop here. We're almost there, but we can never leave our answers with a negative power. That 2's got a power 1 that's positive. That n's got a power that's 13, that's positive. But this m here has a negative power. So we know that trick to make it a positive power, it simply goes on the bottom. And we know that this is sitting on an invisible 1. So that m to the power of negative 9 will go on the bottom, and it will become positive. So our final answer will be 2, n to the power of 13, they both stay on top, but that m to the power of 9 is now on the bottom, and please make sure it's no longer a negative, it's a positive. There is nothing else we can simplify, and that is our answer. Now with our second question, it's this one here, and it looks similar to the other one, and we'll be doing the same thing except for one step that I'll do a bit differently, just to show you another way of working this out. So first, let's get rid of our brackets. So the 5 is outside the bracket, so I have 5 here. Now 3 times 3 is 9, So b to the power of 9 minus 2 times a 3, that makes a negative 6. So c to the power of negative 6 times 3 once again here is on the outside, so it stays out there. 1 times a negative 4, so it will be b to the power of negative 4. And c to the power of 5 times negative 4 is negative 20. So just double check your powers to make sure your negatives and positives are okay. All right, now if you remember the question that we did before, at this stage you can simply add the powers of the same base, and the numbers 5 times 3 will just be 15, and you'll get, and then continue on from there. But I'm doing this a bit differently just to show you another way of doing it. I'm going to make my powers that are negative, I'm going to make them positive first. So on this side here, it's over 1. On this side here, it's over 1. So I'm going to bring any negative power that's on top, I'll be putting it on the bottom. So it's going to go on the bottom. And this power here and this power here are both negative, so they're both going to be going on the bottom. And then I'll simplify. So first, let's do that. So we're practicing our negative index law. So we have 5b to the power of 9 sitting on top. They stay there. But c to the power of 6 is now on the bottom and it's positive, times the 3 stays on top because it's got a positive power. That's an invisible one. But the b to the power of 4 goes on the bottom, and c to the power of 20 goes on the bottom, and now they are positive. Now, can you see how we have eliminated? We've removed our negative powers and made them positive. And now let's see what we can do. We will simplify before we multiply. So I've got 9b's on top and I've got 4 on the bottom. So take away 4 from there, it's a 1. 9 take away 4 is 5, so b to the power of 5. Is there anything else we can simplify? No, the c's are on the bottom, so I can't simplify them. So now we just multiply, add the powers of the same base, and we're done. So on top we have 5. If you want to rewrite it out, you can. I don't have any room. So 5 times 3 is 15. B to the power of 5, there's no b's on this side, so it stays b to the power of 5. Nothing else on top. Over, we've got c to the power of 6 and c to the power of 20. So we have to now, because we're multiplying, we add their powers. So 6 plus 20 is 26. And we're done. That's our final answer. So if you did it the other way, where you simply added the powers here at this step and then made any negative powers positive, you should have gotten the same answer. But it's important to know how to do it both ways, because sometimes you have to get rid of any negative powers first and then continue from there. Now with this question, we will be doing the same thing, except now you notice we have fractions as powers. And that's where it can be confusing if you're not confident with your fraction skills. And you notice that the 2 and the 3 are outside the brackets. So we will, in the questions that I'll be doing, we won't have any numbers to a power that's a fraction. Because like I said, that's the last index law that we haven't covered and we won't be covering. I just want you to focus on these index laws that we've covered and getting good at those. So, our first step is, we've got a power out here. Even though it's a fraction, we do the exact same thing. That times that, and that times that. And the same thing on this side. Negative a third times a quarter and times negative 3/4. So you have your calculator to assist you, of course. So we will end up with, I'll show it step by step so you can see what's happening. So P, we've got 2 over 3, and now times a negative 3 over 4 on this side. And then we have a Q, a third, times a negative 3 over 4. Now I'll do this first because I won't be able to fit this side in because it takes up a lot of space with the fractions. So we end up with, so we're just working on this side here. 2. Now have a look. We've got 2/3 times a negative 3/4. So we're going to end up with p to the power of a negative, because we've got positive and negative. Simplify before you multiply. So that cancels out to be a 1. That is a 2. And of course, the 3 and the 3 can cancel out. So we end up with 1 times 1, which is 1, and 1 times 2, which is 2. So p is to the power of a negative half. And our cube will be a third times a negative 3/4. Cancel our 3's, and we're left with a positive and negative make a negative 1 over 4. okay? And that's for this side here. So times, and let's do the same thing for here. So we've got 3, and we've got p to the power of a quarter times a third. Now I'm just going to do this mentally, but you can write it out if you want to, because I can see 1 times 1 will give me 1, and 4 times 3 will give me 12. And of course it's negative, because a positive and a negative make a negative. So that's p to the power of negative 1/12, or 1 over 12. Sorry, it looks a bit messy. And my q, now I'll write the working out just down here. The powers, negative 3 over 4 times negative 1 over 3. Okay, and we can see that it's going to be positive, because 2 negatives are a positive. That cancels out, and we end up with 1 times 1, which is 1, over 4 times 1, which is 4. That's positive. So a positive quarter. So just please make sure you don't make a mistake with your fractions. And like I said, you have to be confident with your fraction skills. Otherwise, go back and practice some of your fraction skills. Okay, so now because we have powers that are fractions, I won't be putting these on the bottom and making them positive, because we have to actually leave it like this because of the fractions. So now all we're going to do is add the powers of the same bases, so the p's and the q's, and of course the numbers 2 and 3, because they're just normal 2 and 3, they will simply give us 6. 2 times 3 is 6. So my answer will have a 6. My answer will also have a p and a q, but now I have to add their powers. So let's do that. So I'm going to do the working out just down here for my p. I've got a negative half plus this p here has a negative 1 over 12. So a negative and a positive will make a negative. So I am subtracting these two fractions. So you can do this on your calculator as well to help you, but I'll do it the long way. So 2 times 6 will give me 12. We need the same denominators. So we end up with negative 6 over 12, take away 1 over 12. And our answer will be minus 6 minus 1 is minus 7 over 12. And that is my power for p. So p will be minus 7 over 12. I'll just squeeze it in there. Now we have to do the working out for q, and I'll just rub it out. Now for q, look at the powers of q. We've got a negative quarter on this side. That comes first, plus the power here is a quarter. They have the same denominators, and let's have a look. Minus 1 plus 1 gives us 0. So we have 0 over 4, and 0 divided by 4 is 0. So the power of q is actually 0. And we know that anything to the power of 0 is 1. So please make sure you don't cross it off and write 0, because that will be wrong. Because then we'd have 6 and then p times 0, which is going to be 0. So that's just going to be a whole number 1, which can just be invisible now. But we're left with, I'll just squeeze it here, 6 and then p to the power of negative 7 over 12. So that's a power. I'll just rub off that little mark there. Oop, a bit too big. All right. Now, we don't leave our answer like this. Because p has a negative power, that's negative 7 over 12, it simply goes on the bottom. So we'll just change colors. So the 6 stays on top, but that's going to go on the bottom. So our final answer, I'll squeeze it down here, will be 6 over p to the power of a positive 7 over 12. That fraction's a power. And that would be our final answer. And we're doing the exact same thing, except we have fractions. And you notice that our numbers don't have any fractions, any fractional powers, because like I said, we're not covering that. Our next question will be question 2G if you're doing that worksheet, and I'll just write it up. Now this question here, you can see it has fractions as well, but we're doing the exact same thing, and our first step is let's get rid of these powers and brackets outside the powers outside the brackets. So the 5's in the brackets, so we end up with, well, 1 times 2 is just going to be, oh, that came out really crooked. Let's try again. And that's a bit better. All right, we've got 5 to the power of 2. 6 times the positive 2 is p to the power of 12. Now a third times 2, so I'll just do some working out here. A third times 2, and a 2 is really over 1, we'll be left with 2 over 3. So I have q, and the fraction is 2 over 3. And there we go. On the bottom, 25 is on the outside, so the 25 can stay on the outside. In the brackets, I've got a half times 2 over 3. So a half times 2 over 3. The 2's can cancel out to give me 1. So I'll be left with 1 times 1 is 1 over 1 times 3, a third. So p to the power of a third. And then my q down here, I've got a quarter times 2/3. So I'll just do some more working out here. A quarter times 2 over 3, or 2/3. That cancels out to be a 1. That can cancel out, divide them both by 2. And 4 divided by 2 is 2. So we end up with 1 over 2 times 3 is 6. So it'll be q, and then to the power of 1 over 6. Okay, so just double check you're working out. You notice that we have no negative powers, which is fine. And I'm going to do one more step, and that is, see how I got 5 to the power of 2? 5 to the power of 2 is actually 25. And I'm not going to rewrite this. I'm just going to cross off that 25 and cancel out the 25. So all I'm left with now is, because I haven't got enough space, but you can rewrite it more than once, 25's cancels out to be 1. That's what I am left with. Now, how do we cancel this? Because I've got 12 p's on top and a third, or 1 over 3 p's on the bottom, and 2/3 q's on top, and so on the bottom. We have fractions. How do we cancel out the fractions? That's where it starts to get a little bit more complicated, because we do have fractions, and it's not as easy to go, for example, 8 take away 2 or something. It's getting quite hard. This is where you have to now, remember the vinculum means division. It means to divide. So this is where I want you to now rewrite it this way. P to the power of 12, and then q 2/3, or 2 over 3. That means divide. So we'll have it written this way, divided by p to the power of a third, and q to the power of 1/6, or 1 over 6. And the reason why we're doing it this way is because you will notice that division, when we divide the same bases, all we have to do is actually subtract their powers. So we'll be subtracting their powers. So let's do that. I'm going to clear the page, and just so I can have more room. Okay, so now, like I said, we are subtracting our powers. So our answer is going to have the base p and the base q. And now let's work with our fractions and numbers. So 12, so working with our p for now, 12 take away a third. So I'll just do some working out here. 12 take away a third. Use your fraction skills. That 12 is really over 1. We need to have the same denominator, so times by 3 and times by 3. And like I always keep saying, you can use your calculator as a tool to help you to work this out faster if you wanted to. And then we've got 12 times 3 is 36 over 3. Take away 1 over 3. So we have 36 take away 1 is 35 over 3. Now, don't write it as a mixed fraction. When we have powers that are fractions, we leave them as improper fractions. So p is to the power of 35 over 3. And now I've got to subtract 2/3 and 1/6, and I'm done. So I'll just write this out so I can have some more room. So like I said, leave it as an improper fraction. And with my q, the powers of q, I've got 2 over 3. Start from this side, of course. Take away 1/6. Once again, using our fraction skills, we need the same denominator. So I'll times this by 2 and times that by 2. So we're left with 4 over 6. Take away 1 over 6, which leaves me with 3 over 6, which can be simplified to a half. Divide them both by 3. It gives us a half. And I'll change my colour so they can have the same colours. Q is to the power of a half. And that is our final answer. There is nothing else that we can do. And that's it. They're both positive powers, so they just stay there.